In this video, we are going to talk about water activity, a very important concept in the field of food science and technology. I'll be making use of cookie as an example to describe the entire process and phenomena of water activity and its significance in food science. So let's dive in. Sam is an American traveler spending a week in Paris. He decided to see all the major attractions in Paris. While in Paris, it occurred to him that he ought to try the local cuisine, as France is a leader in the manufacture of several bakery products, including baguettes and croissants. One day, after visiting the Louvre, he was exhausted and wanted to grab something quick to eat. He went to the nearby bakery and bought a few croissants and cookies. He loved the croissant but was disappointed to find that his cookies tasted hard and were not soft like the ones he gets in the US. Let's take a look at this case for a moment. The problem setting here is Sam's cookies did not have the desired texture. According to Sam, the cookies that he bought from the shop or the bakery was very hard. In food science, we have a concept called as water activity. So water activity is given as fugacity of solvent in a solution to fugacity of pure solvent under standard measurement conditions. So fugacity, it refers to how easily a molecule can escape from a solution. At constant temperature and low pressures, water activity becomes equivalent to relative vapor pressure. And this relative vapor pressure is given as vapor pressure of solvent in a solution to vapor pressure of pure solvent at a given temperature and pressure. In fact, the error value is so low, it is approximately 1% that you can substitute water activity for relative vapor pressure and vice versa. Relative vapor pressure is given as equilibrium relative humidity by 100. So what does it mean? It means that at a given point in time, if we know the relative humidity, we can calculate water activity. But how does this relate to Sam's cookie not having desired texture? So two things can happen in case of cookies. If the relative humidity of the surrounding is greater than the water activity of the cookie, cookies tend to absorb water from the surroundings. So cookies generally they tend to have low water content. So when placed in an environment which is high relative humidity, there is movement of water from region of its higher concentration, which is air, to region of its lower concentration, which is cookies, till equilibrium is reached. Meaning, cookies tend to gain moisture from air and thus become soggy. Similar is true for foods that have high moisture content. When they are placed in an environment where the relative humidity of the surrounding is lower than the water activity of the cookies, cookies tend to lose water and thereby confer dry texture to cookie. As texture is important for consumers, we can prevent this in case of Sam's cookies in one of the following ways. So, Sam, he likes his cookies to be very soft and soggy because this is what is sold in the United States of America. So, what he can do is he can place his cookie in an open container in a room which has high relative humidity. He can leave it there for some time, then come back. His cookie would have become soggy or soft the way he wants it to be. Second is to make cookies that have water activity similar to relative humidity of storage rooms, just to ensure that if you're making cookie that is moist, it does not lose water to the surroundings. Thank you for staying with me through the video. In case you have any queries, please feel free to put them in the comment section and I'll get back at the earliest.